All right, let's use this simple concept here this simple problem here to illustrate the concept of present value. What's something worth today? All right, so you're promised a stream of cash flows, cash payments, totaling $1,000 spread over the next 4 years. You don't get them evenly. You're going to get $100 1 year from today, $200 2 years from today, $300 3 years from today, and $400 4 years from today. So 100 plus 200 is 300, plus another 300 is 600, plus the 400 is $1,000. Grand total $1,000 in exchange for $800 today. Now what I've set up is a timeline. The time, generally, this is how many periods in the future. So today is 0 years in the future. The first payment a year from now is 1 year in the future. The second payment is 2 years in the future, and so on. All right, so in exchange for your $800 today, because that's what they're asking you to pay, $800 in order to get $1,000. Is it a good deal? Now you have the money. The money is sitting in an investment account that's already earning 8% already. So that's the idea. The opportunity cost of your money is 8%. That means well, this is the opportunity cost. That means that you can earn 8% on the money, or you can invest it in this. But what we don't know here is what you're earning, what rate you'd be earning on the 800. Now, you're going to get $1,000 back. All right, that's an extra $200. But it is actually spread over a 4-year period. So in order to be able to calculate what rate of return that is, we need to turn to some fantastic mathematics, or we'll let the computer do it. All right, so the first thing that I want to do is illustrate this concept of present value. Obviously, since I can earn interest on money today, that if I took the 800 out and gave it to this other person, I wouldn't be earning 8% on it. So the opportunity cost, 8%. I can figure out what the value of $100 a year from now would be if I just left the money in there at 8%. Okay, so there's a fairly simple formula on that, and the formula would be the future value divided by 1 plus the interest rate raised to the amount of time until I get the money. Okay, so simple mathematical formula here. And for this 1 year period, it'd be $100 divided by 1 plus 0.08, or 8%, raised to the first power. For the second one, it would be $200 divided by 1.08 to the 2. All right, that means I'm going to earn interest on interest. So after 1 year, I'll have 8% of $200, so that would be another $16. And then that $16 plus the original $200 will also earn interest in the second year. So that's what they call the magic of compounding. Nothing magic about it, it's just arithmetic. All right, and that's the magic of compound interest, is that most people are so bad at simple arithmetic, it seems like magic, I guess. So those are the formulas that we would use to take what this $100 to be received a year from now, what is the equivalent amount of money today that could earn 8% interest and still be worth $100 a year from now. All right, so, well, I just paste those off to the side. Those are the formulas. And to put this into Excel ease, then that cell divided by 1 plus 0.08, 1 plus the interest rate raised to the number of periods. Okay, and I just copy that down. And what that means is if I had $92.59 today, and it earned 8% interest over the next year, that at 1 year in the future I'd have $100. This also means that if I started today with $171.47 and earned interest, I'd earn $13.72 over the first year. And then I'd also earn interest on the original $171.47 plus the $13.72 over the next year. So the math for all that is that amount times 1 plus 0.08 yx2 minus 1. I know there's an error in the formula. All right, so I'd earn a grand total of $28.53. Or I'd have $200 in the future. So essentially, if I follow through on each of these, what that means is that if I started with this amount today, that would generate $100 a year from now. This amount would generate $200 a year from now. This amount would generate $300 3 years from now. And this amount would generate $400 4 years from now. So if I take the sum of these numbers, that's how much I'd have to start with today in order to be able to earn enough interest that between the amount I start with, $796.22, and the amount of interest I'd earn on that $796.22, I'd have $1,000 total. Okay? That means that the present value of this promise of 100, 200, then 300, then 400 is only worth $796.22. Somebody wants to charge me $800 for something that's actually worth $796.22. All right, is that a good deal? Well, generally no. If somebody's charging you $800 for something worth only $796, well, that generally means that they're overcharging you or underpaying you with the interest. Now, there's also a shortcut for this, and it's called the Npv function. The Npv function in Excel gives you the present value of uneven cash flows. The function is equals Npv, the interest rate, comma, and then the cash flows. And as long as they're next to one another in a spreadsheet, then it's fairly simple to just do equals Npv open parens 0.08, 8% the interest rate. You can also type in 8% and then cover up the cash flows. So that $1,000 received over 4 years is worth $796.22. It's the exact same number I got from taking the present value of each of the cash flows using these basic arithmetic formulas. Well, Excel doesn't do arithmetic better than you do, it does it faster. So that's all it did was do these calculations based on how you set up the problem. It knows that it means to take that first cash flow and discount it 1 year, the second cash flow 2 years, and then so forth. Okay? So that's what I would call the present value of these cash flows. If I wanted to know what rate of interest you'd actually be earning, that's called the internal rate of return. And the internal rate of return formula is equals IRR and then give it all the cash flows. All right, so the IRR for this and this time I have to also cover up the cash flow of what I'd have to invest at time 0 or today. Oh, well, that's 8% too. No, not when you show a couple of decimal places. That means that what they're promising you is something that'll earn 7.83%. That's less than what you're making now. Does that seem like a good idea? You could take money that you're currently earning 8% on and reinvest it at less. Okay, well, that's probably not a good idea. That's a simple example here, but this is the type of thing businesses are faced with every day. The cash flows tend to be larger But this is the type of investment decision that corporate managers make constantly. Do we buy a new delivery truck? The new delivery truck will cost $800,000, and it'll generate cash flows of $100,000 the first year, $200,000 the second year, $330,000 or $400,000 the fourth year. Is that earning? If we have to pay 10% to borrow money, and this is only earning 7.83, well, that'd be a bad deal. If I can borrow money at 4%, though, this would be a good deal. It depends on what your opportunity cost of money is. So in our simple example, we said it's 8%. With a corporation, it might be higher, it might be lower. But this is the process that we follow using time value of money to evaluate business decisions.